Okay, today we will learn about differentiation. Suppose you have a function y, function of x. Here x is independent variable and y is dependent variable. Okay, x can take any value and correspondingly y will get the value in according to this formula. Suppose for an example, suppose say y equal to x square or y equal to sin x. So here if you put a value of x, then you will get a corresponding value of y. So these are called y function of x. Okay, it can be any function. Now what is differentiation? Suppose you plot a graph. Here this side is x and this side is y. So suppose there is a graph of x square. So x square plus something, and in this graph for each value of x you will get a corresponding value of y. Y is function of x. So now if I say that find derivative of y with respect to x, how will you do that? The concept is, if you change x slightly, suppose this point is x naught, and if you change this value by delta x, correspondingly the value of y will also be changed. Suppose this value is y naught and this value is y naught plus delta y. So here y naught equal to f of x naught and y naught plus delta y is f of x naught plus delta x, and now the change of y is delta y and the change of x is delta x. So if you divide delta y by delta x, you will get the slope of this. So delta y by delta x, and that will be equal to f of x naught plus delta x. From this if you minus y naught, f of x naught, then you will get delta y by delta x. Now the concept is, if you make this delta x smaller and smaller, then this slope will be equal to the tangent of this point, tangent at this point. So limit delta x tends to 0, delta y by delta x will be limit delta x tends to 0, f of x naught plus delta x minus f of x naught by delta x, and we will say this value as ddx of y. That is, we will read this as derivative of y with respect to x, and the definition of this is limit delta x tends to 0, delta y by delta x, and that is equal to limit delta x tends to 0, f of x naught plus delta x minus f of x naught by delta x, and we are finding this value at x equal to x naught, because we are finding the derivative of this function at this value x equal to x naught. So generally if you find, you can find in any other value of x. So generally dy by ddx of y at any point x will be equal to limit delta x tends to 0. If I generalize this, then it will be x plus delta x minus f of x by delta x. This is the definition of derivative of y with respect to x. So we'll find an example. Suppose f of x is x square. Okay, so if I change x by delta x, If I change x as x plus delta x, then f of x plus delta x will be x plus delta x whole square, because in place of x we'll write as x plus delta x. So now what will be dy dx? Dy by dx will be limit delta x tends to 0. F of x plus delta x means x plus del x whole square minus f of x is what? X square by delta x. So if you find that limit delta x tends to 0, x plus delta x square is a plus b whole square means x square plus 2 into x into delta x plus delta x square. Delta x is very small, so delta x square will be almost negligible. X square will be cut out by delta x equal to limit delta x tends to 0. As delta x is tends to 0, that means very small, so we can neglect this value, or you can set this value as 0, 2x into delta x by delta x. But we cannot make this value as 0. Why? Because then it will be 0 by 0 and that is undefined. But we can make this value as 0, because 0 plus something means that will only survive. So now 2 into x into delta x by delta x, and now the thing is delta x tends to 0. Tends to 0 means it is as close as possible to 0, but it is not equal to 0. As delta x is not equal to 0, so delta x by delta x will be 1. That means that only there will be 2 into x. So that's the reason why ddx of x square y is equal to x square, that is 2x. And from this we get derivatives of many functions according to this. This is the definition of derivative or differentiation. The name of the process is differentiation, and here we read it as derivative of y with respect to x. Thank you.